Jump Game 4, count the fewest moves to the last cell. Each move is one step left, one step right, or a jump to any other index that holds the same value. Given an integer array ARR, you begin at index 0. In one step you may move to I-1, I+1 if in bounds, or teleport to any index j not equal to I where ARR at j equals ARR at I, return the minimum number of steps to stand on the last index. Example 1, the array has length 10, the last index is 9. Both index 0 and 4 hold 100, so the first jump can teleport from 0 to 4 in one step. From 4, step left once to index 3. Indices 3 and 9 both hold 404, so one teleport finishes at the last index. That is 3 steps total. Example 2, a single element. You already stand on the last index, so 0 moves are needed. Treat the array like a street of lots. Each move is either a one-step walk to an adjacent index, or a portal hop. In one beat you may land on any other index that holds the same number. Park on index 1 where the value is -23. Your sidewalks touch 0 and 2, index 2 is the other -23, so it glows as a portal partner. Before the walk begins, scan once and bucket every index by its value. That hash map is your directory of portals. When you stand on a value, you already know every legal teleport target without scanning n again. Shortest path in an unweighted graph is breadth first search. Depth 0 is just index 0. The next layer is everything one legal move away, walk right to index 1, or portal from 100 at 0 to the other 100 at index 4. Ripple outward layer by layer until you hit the last index. The subtlety is cost control. The first time you dequeue an index whose value is 23, you enqueue every other 23 index once. If you left the list in the map, a later 23 could requeue the whole clique and blow the time budget. So after that first expansion, erase the 23 entry from the directory. Those indices stay visited in the BFS sense, the portal list is single use. The portal directory maps each value to every index that holds it. We start breadth first search at index 0 and expand wave by wave until we reach the last index, that yields the minimum number of steps. Dequeue index 0. The right neighbor is index 1, unseen, enqueue it. The value 10 lists indices 0 and 3, 3 is new, so enqueue it too. All 10s are now accounted for, so remove the 10 row from the map. Visiting 10 again must not rescan the whole group. The queue is 1 then 3, that is distance 1 from the start. Pop index 1. Walk to index 2 and enqueue it. The 20 row still lists 2, after enqueuing, delete 20 from the directory so later 20s do not trigger another bulk expansion. Pop index 3. It is also a 10, but the 10 entry was already cleared, so same value expansion does nothing, no wasted scan. The only fresh move is the neighbor to the right, index 4, the last index. Enqueue it at distance 2 from the start. The optimal answer is 2 jumps, for example 0 to 3 by the 10 portal, then 1 step to 4. If we dequeue index 2 next, the 20 list is already gone and both neighbors are visited, so nothing new is added. Deleting each value row after its first wave is what keeps total work linear in n. Let n be the length of ARR time is linear, each index is dequeued at most once, and each value's index list is emptied once after you expand it, so all portal work adds up to order n. Space is order n for the queue, the visited set, and the hash map that lists indices per value. Pseudocode for jump game 4, function minjumps takes the array. Let n be the length. If there is at most one index, 0 moves are needed. Build a hash map from each value to every index that holds it. Start breadth first search. Q holds pairs of index and distance, scene holds index 0. While the queue is not empty, pop the front pair as current index I and distance D. If I is the last index, return D. Try the two neighbors I-1 and I+1. If J is in bounds and not seen yet, mark J seen and enqueue it with distance D+1. For every index J that shares the value at I. If J is not seen, mark J seen and enqueue J with distance D+1. Clear that values list in the map so we never expand it again. If the queue empties without reaching the end, return -1.